Now that you know how to divide imaginary numbers by a monomial, now we'll look at how to divide imaginary numbers by a binomial. When we divide by a binomial, it'll be very similar in dividing by a monomial because we still don't want to have imaginary numbers in our denominator. We'll get rid of imaginary numbers in our denominator now by multiplying the top and bottom by a conjugate. A conjugate is two binomial expressions that differ only in sign. So for example, 3 minus 4i and 3 plus 4i are going to be conjugates. As well, negative 5i plus 7 and negative 5i minus 7. So notice that the sign in between the two terms is the only thing that changes. The first term does not change at all. So as I said before, we are going to rationalize a binomial denominator by getting the imaginary numbers in the denominator gone by multiplying both top and bottom, so both numerator and denominator, by the conjugate of the denominator. And I'll kind of explain why as we go through the first example. Then, of course, I'll make sure and check if my expression can be factored. And I do have to make sure that I do not reduce with add or subtract once again. So let's look at our first example. So first thing I notice is I have an imaginary number in the denominator, and because I have two terms, it's a binomial in the denominator. So according to my rules up top, I'm going to multiply top and bottom by the conjugate. Well, I know that the conjugate differs in sign in the middle, so I'm going to multiply top and bottom by 3 minus 2i. When I do, on top I'm going to have to distribute that 4 to both terms, and by distributing to both terms I get 12 minus 8i. And on the bottom, notice what happens if I go through FOIL. First times first is 9, outside times outside is minus 6i, inside times inside is plus 6i, last times last is minus 4i squared. Well, my middle terms, because I multiplied by my conjugate, my middle terms end up dropping out. So when my middle terms drop out, I end up with 12 minus 8i still on top, all over 9 minus 4. And instead of writing I squared, I'm going to write that as negative 1. So I get a final answer of 12 minus 8i all over 9 plus 4, or 12 minus 8i over 13. And I noticed that there isn't anything, even though 12 and 8 have a GCF of 4, factoring that 4 out isn't going to help me because 13 can't be reduced by 4, so I'm going to leave it like that. And there's my final answer. Let's look at another example. On example 2, once again, I notice that I have an imaginary number in my denominator. I want to get rid of that. Because it's a binomial, I'm going to go ahead and multiply by the conjugate. So my conjugate of my denominator will be 3 plus 2i. And I'll do the same on top, 3 plus 2i. And then on top, I'm going to go ahead and FOIL that. So I get 15 plus 10i minus 18i minus 12i squared all over, and again on the bottom I can FOIL, but I know that when I FOIL, I can take a shortcut from FOILing if I notice that this is in the form of something minus something times something plus that same something. So in other words, this is in the form a minus b times a plus b. So I can FOIL like I did in the first example, or by noticing that I can now use my formula that tells me in the denominator I'm going to get a squared minus b squared, and I have to remember to square all of b. So then cleaning up my top and bottom a little bit, I can see that I can combine my two terms in the middle on top. So 10 and minus 18 is negative 8i minus 12, and negative I squared is times negative 1. 3 squared is 9, minus 4i squared. Well, moving down here, that then gives me 15 minus 18i plus 12 all over 9 minus 4 times negative 1. So now on top I can combine my 15 and my 12, and I get 27 minus 18i all over, again I have 9 plus 4, which is 13. And just like in the last one, I see I could factor something out of the top. I see they have a GCF of 3, but it's not going to cancel with 13 anyway, so I'm just going to go ahead and leave it as is. And I believe I have one more example. So if I look at my final example, and notice again that I have a denominator with an I, so I multiply top and bottom by my conjugate, 4 minus 8i. Foiling on top, I end up with 8 minus 16i minus 48i plus 96i squared, all over, again using my formula a plus b times a minus b on the bottom. I get a squared minus b squared, giving me 8, 16, and 48 is 64, so minus 64i plus 96 times negative 1, all over 16 minus 8 squared is 64i squared, so I get 8 minus 64i minus 96 all over 16. I know that I squared is going to become negative 1, so minus 64 times negative 1. I do have a little more room left, which gives me 8 minus 96, which gives me 88, negative 88, minus 64i, all over 16 plus 64. So I get a final answer of negative 88 minus 64i, all over 80. Except I'm actually not done because I noticed that, oops, I can't move my sheet anymore. I noticed that negative 88, negative 64, and 80 can all be divided by 8. So I'm going to take out an 8, and when I do, I'm going to say I have, I'm going to write it way over here, which is really bad for showing my work, but I'm out of room. So I'm going to have 8 times negative 11 minus 8i all over 80. Well, now I can reduce top and bottom now that it's multiplying by 8, leaving me with negative 11 minus 8i on top and 10 on the bottom, and there is going to be my final answer after reducing.